during pregnancy is 30 pounds with a standard deviation of 12.9 pounds. So we know our mean, we know our standard deviation. An obstetrician obtains a random sample of 35 low-income patients. So what would that be? And determines their mean weight gain was 36.2 pounds. Does this result suggest anything unusual? So, first we have to check. Did I tell you this was normal? No. But
There's more than 30?
More than 30.
N is bigger than 30. So it's normal. We can assume that. Okay, so now, what would be the mean of my sample?
30.
What is my standard deviation of my sample?
12.9, you're right over 30.
Okay, so if I do that, we get 2.1. All right, so now we want to find the probability. All right, it's asking us if this is unusual. We want to find, we know their mean was 36.2. I can't just find the probability that my mean is equal to 36.2. The normal distribution, we have to be less than or greater than. Which one do you think I should find if I want to see if it's unusual? Greater than, because my average is 35 or is 30, so I expect it to be less than, right? So if I find the probability being smaller than this, it should not be insignificant at all. So find the probability that we are greater. So we need to get our Z. So Z is our value minus the mean divided by standard deviation. So I get a Z of 2.84. So find the probability Z is greater than 2.84. So greater than is 1 minus. Then you go to your normal table. And if we look up 2.84, we get so that's 0.0023. So there's only a 0.2% chance that somebody is greater than this. So would this be unusual?
Yes.
So that would either mean we had a bad sample or that low-income group was different from the population in some way. All right. So now, moving into section 8.2. This is talking about a sample proportion. So we were talking about the sample means yesterday. Now I want to look at sample proportions. Suppose I want to determine the number of households in Monroe City that would favor a tax increase to fund a new baseball field. So ideally, if I want to know if it would pass, I would ask every household, right? Is that always feasible? No. So we can't usually talk to everyone, so we would probably get a sample and find a proportion. That proportion is called P hat. It's P with a little hat over the top. And it's my sample proportion. It's saying in my sample, X would be the number of people that said they were in favor, N would be the number of people I talked to. Okay, so I could get that proportion for my group. For example, in a poll, 1,745 registered voters were asked whether they approved of the way George W. Bush was handling the economy. 349 responded yes. If I want a point estimate, when I see point estimate, that means P hat, for the proportion of registered voters who approved of how he was handling the economy. So P hat is just X over N. X would be the number of people that said yes, which is? N is the number I talked to. So we get 0.2. That's a point estimate. Now, if we look at this, the distribution of these point estimates, it has some similarities with what we talked about yesterday. If my sample is big enough, it becomes normal. The center is that p-value for the population, so it's our population proportion. Our standard deviation, just like we saw yesterday, it gets smaller as the population increases. So the important thing that we need to know here, if I'm talking about my distribution for p hat, this one has a slightly different requirement. We can say it's normal if n times p times 1 minus p is greater than or equal to 10. Okay, there's a big long explanation I could give you for why that is, but just trust me on that one. All right, so for the mean, my requirement to be normal is bigger than 30. For the proportion, n times p times 1 minus p has to be bigger than 10. The mean is my population proportion, and my standard deviation is found by this formula. Now, just like everything else, we're not memorizing all this stuff. The only thing you actually have to know is the criteria. That for x bar, the sample has to be bigger than 30 to assume it's normal, and that n times p times 1 minus p is bigger than 10. That is not on the formula sheet, but the others are. So under chapter 8, you have the first bullet is the mean and standard deviation for x bar. Second one, mean and standard deviation for p hat. All right. This does require that all my values are independent. We kind of start assuming independent if our sample is big enough. As long as it's not more than 5% of the population, we can totally assume that they are independent. So, if I look at this one, according to a poll, 42% of registered voters believe the president should be impeached. Suppose we obtain a simple random sample of 50 voters and determine which voters believe the president should be impeached. Describe the sampling distribution of the sample proportion. So the describing piece, what I'm wanting is, does it meet my criteria, and tell me the mean and standard deviation. And we are talking about the sample proportion, so that's p hat. So the mean for p hat, standard deviation for p hat. Criteria for p hat. I need n times p times 1 minus p to be greater than or equal to 10. What's my n?
50.
My p, that's what you is my proportion of the population. So my p is 0.42. 1 minus 0.42. And we get 12.18, so we can assume it's normal. The independent is technically a criteria too, but most of the time we won't be able to check that. Do I know my entire population? No, but would you assume 50 is less than 5% of our total voting population? Yeah. So most of the time you can't really check that one, we just are assuming it, but the normal we definitely need to verify. My mean is just my sample proportion, or sorry, my population proportion, my p, which was 4.42. My standard deviation, if you look at your formula, the square root of p times 1 minus p over n. So p is 0.42, 1 minus 0.42 over my n, which was 50. And if I do that, I get my standard deviation to be 0.0690. So if I'm asking you to describe the sampling proportion, or the sampling distribution, I'm asking you to check your criteria, give me the mean and standard deviation. look at a couple examples. So these, I think I left you a blank slide after each of these, just so you had enough room to write everything down. According to the Centers for Disease Control and Prevention, 18.8% of school-aged children aged 6 to 11 years were overweight in 2004. What's this 18.8? That's my P. Yeah, that percent is your P. And that is a good thing to note. The P is always a percent. It's our proportion. In a random sample of 90 school-aged children, what's my 90? What is the probability that at least 19% are overweight? Before I actually solve my problem, we need to check our criteria. Okay, my N was 90. My P, 0.188, 1 minus P. And that's 13.74, which is definitely greater than 10. So that one's good. That means we can assume it's normal. Is 90 less than 5% of my total population? We're going to assume all school-aged children, 90 would be less than 5%. So like I said, most of the time we can't verify it. We're just making sure we're thinking about it. So part A. I want the probability that at least 19%. If I'm talking about a percent, then I'm talking about a p hat. So at least, that means greater than or equal to 0.19. What do you think I have to do first? We need our mean and standard deviation. So the mean for p hat is our population proportion, which was?
0.188.
Our standard deviation for p hat is the square root of p times 1 minus p over n. It's 90. Okay, and like I said, those are straight from your formula sheet. And so our standard deviation is 0.0412. So now that I have those, what do I need to find? Z-score. So Z is our value minus the mean divided by our standard deviation. So we get the probability that Z is greater than 0.048, so 0.05. To do greater than, we do 1 minus, and then we go to our table. 0.05 is subtract those, we get 0.4801. So there's about a 48% chance that at least 19% are overweight in our sample. Are we okay with that one? B. So same scenario, we have our 90 children. Results in 24 that were overweight. What might we conclude? Let's find our point estimate. We're talking about P's, so we need a proportion. If 24 were, how would I get my P hat? So that gives me a 0.2. 0.2667. Okay. We want to decide if this is unusual or not. Would I expect my group to have a weight, or lost my train of thought. Would I expect more or less than this? My population was 0.188, so I expect less. So if I find the probability of being smaller than that, will it give me anything significant? No. So to really check if this is unusual, we need to find the probability that it's greater than that. So we need our z. So our value minus the mean divided by our standard deviation. We know greater than, we do 1 minus. We look up 1.91. And so if we subtract that, we get 0.0281. Cannot write today. Writing the wrong thing. Okay. Is that unusual? Yes. This is unusual. Which means our sample might be different than the entire population. Okay, this isn't impossible. But there is less than a 3% chance of me getting a sample like this. So that's probably a pretty strong indicator that something else is going on. For some reason, my group is very different from my population in some way. So there's probably some lurking variable out there that I'm not considering here. All right. Questions on that? So once you get the initial setup, really all these problems are the same as what we were doing in chapter 7. The difference is we do have to check our criteria, make sure it's normal. We find our mean and standard deviation. After that, it's just getting our z and using the normal table. So if I look at this one. According to the National Center for Health Statistics, 15% of Americans have hearing trouble. What's that 15% represent? Anytime you see a percent, it is probably our population proportion. In a random sample of 120 Americans, what's my 120 represent? What's the probability that at most 12% have hearing trouble? What do I need to check first? Would my sample be less than 5% of my total population? 120 Americans, is that less than 5% of all Americans? Would assume, yeah. Okay, then we need to check our N, so 120, times P, 0.15, times 1 minus P, has to be greater than 10. That's greater than 10, so that means it is normal. All right, that's what tells me that I can use my z's on this. We are going to need our mean and our standard deviation before we do any problems. What's the mean of my sample? How do I get my standard deviation?
Square root of P over N.
P
1
times
minus P.
1 minus P over N.
So
My standard deviation 0.0326. So now let's do probability. I want the probability that at most 12%, so a percent is always my proportion. At most means less than or equal to 0.12. So we have to get our z. Z is our value minus the mean divided by the standard deviation. So I'm finding probability that z is less than or equal to negative 0.92. Less than is what my table gives me, so I look up negative 0.92. Part B. Suppose that a random sample of 120 Americans who regularly listen to music using headphones results in 26 having hearing trouble. What might you conclude? What do I need to find?
Criteria.
Well, we already have our criteria from before, so we can carry that over. So we need our p hat, which is so 0.2167. And remember, my mean, so child.
I'm laughing because they're like,
So childish.
I was keeping it together.
Right.
Yeah, Grady's got my back.
So my mean is 0.15. That's smaller than this. So if I want to find if it's unusual, I need to check the probability of being greater. Now, if my p hat had been like 0.1, what would I have found?
Less.
Probability being less, because that was smaller than my mean. Alright, so now we get our z. So our value minus our mean divided by my standard deviation. Probability that z is bigger than 2.05. So greater than is 1 minus. If I look up 2.05, that's 0.9798. We get 0.0202. Is that unusual?
Yeah.
So what might you conclude?
Pop sample is different.
Or something along the lines that maybe using headphones increases the probability of having hearing loss or something like that. Okay. Any questions? So, game plan. We have a quiz Friday over chapters 7 and 8. Tomorrow I would like to do some review for part of the class. So you have like a little bit of time right now to start your homework. You'll have the majority of class tomorrow, and I will probably take 15-20 minutes tomorrow to do some review as well. Okay?
And we'll grade that tomorrow afternoon also, or will we?
I probably won't grade the chapter 8 homework until Friday. We'll
So
grade it
that-
before the quiz.
If we don't get done tomorrow, we can still work on it.
Yep. Yep. So the homework is due Friday